Hello, everyone, and welcome to another edition of Threat Thursdays. I'm the VP of Product over here at Scythe, Adam Mashinchi, and today I'll be walking you through obviously this week's threat, which in this case is HoneyBee. Now, most of the threat intelligence we based this technique off of, or the TTPs that we're going to present here today off of, was from a report by the team over at McAfee, shout out to them, who broke down all of the layers of the HoneyBee threat actor and all of the behaviors it did and the way it did injection and just kind of everything across the board and aligned it to MITRE ATT&CK. So it made replicating this very, very easy from a Scythe perspective. Now, obviously, we're going to really focus on the post-exploitation behaviors today. And those are the things that in our the JSON blob we're going to put up at GitHub, those are the things that you'll be able to emulate quickly and easily. So it's most of the things after the Word doc dropper here in this image by McAfee. So moving forward, let's go ahead and just open up the Scythe interface here and create a threat. And so we'll call this HoneyBee example. And we'll go ahead and, again, it's Windows, we'll move forward. We'll just use HTTPS for command and control and exfiltration today. But one of the things I really want to make sure we specify here is under our signature avoidance, the PDB path and compilation timestamp. And the reason I'm calling those out is because they have really explicit values here based on the threat intel that we've got for HoneyBee. Specifically, the PDB path is here. And the compilation timestamp is always on this day. I'm going to add those in. And those will be what we define for every payload we generate here in Scythe for the HoneyBee threat. Moving on, I've actually gone through and already designed out the threat automation. Again, that's what we'll be sharing up on GitHub. It can be imported through the Migrate Threats option. So here, I'll just go ahead and import that really quick under existing threats, and we'll go ahead and do, there we go, HoneyBee. And we'll walk through all of the steps that this does here in a little bit, but for now, I'm happy with my automation, and we'll go ahead and click Next, start the campaign, and now we'll have the ability to generate a payload which will behave in all the ways we expect. So if I go ahead and download 64-bit exe, and again, we can detonate this however we'd like. We could use DLLs or run DLL32 for leveraging that, or Metasploit to inject it. But today, I'll just be detonating it via one of the 64-bit EXEs we generate. So really quick, we'll go ahead and fire this off on an endpoint that I've got once I prep that. So looking at this Windows machine, I've got this payload here, and I'll go ahead and detonate this. And while this is running, I'm actually seeing all this firing in real time over here on my Scythe instance, which I'll jump over to here in a moment. But for now, I want to leave it on this screen because one of the things we're doing in this thread is we're actually prompting the end user for user access controls based on the integrity of the current Scythe binary process. So I'm running as a standard user right now, and we actually have written in an if statement into this payload. So it's detecting the integrity, and based on that value, it's either going to prompt me for UAC or not. Now, oh, there it is. So in this case, I'm just going to go ahead and approve through that and elevate. And this is us just kind of taking a shortcut and pretending as this is the 0 day, if you will. So regardless of the privilege escalation method chosen, we really want to get to the post-exploitation behaviors. And we want to be able to run a few things as an admin. So we've gone ahead and prompted that. Now, meanwhile, while we've been conducting these operations here on this Windows box, Scythe has been at work at having all these behaviors go. And so here you can actually see we've got two processes. The first one, which upon escalation, we actually had it terminate its process and then jump right into, once elevated, the actual behaviors based on a series of if statements. And so here we can see that it's touched down, it's loaded, it's found its integrity, and now we're off to the races downloading arbitrary files to the temp directory from on that Scythe box that we've compromised. So while this goes, I'm actually going to go ahead and show everyone a little bit about the automation that we've defined here. So if we jump over to show campaign details, you can see that it's that same linear and yet logic-based Scythe automation language that we're utilizing here. And so we're actually doing a check and everything's MITRE ATT&CK aligned as usual, but we're doing a check to see what the integrity is. And so in the event of we are already at a high integrity place, we can jump forward to step 7 and begin the behaviors. But if not, we actually went through and loaded that elevation prompt. And in the event the integrity and elevation checks didn't work out, we just go ahead and bail out of this thing. But assuming everything worked, we actually are loading the downloader module from site over the C2 channel, injecting it into memory, and then firing off a series of commands. And in this case, we're dropping the same files or the same file names in many cases that HoneyBee actually does. So for example, setup.cab, that's a specific IOC that HoneyBee drops. These install 1 and install 2 are actual batch scripts. So we actually took the ones from the McAfee report and are dropping those on this endpoint. And so we're downloading all of these things to the compromised host directly from the site server via our virtual file system. Now, once we've dropped all of those in the temp directory, we then get to do some more fun behavior things. In this case, we actually are creating an empty file called install.bat, which is just zeros and ones. There's nothing there. And then we're going to go ahead and try to fire that batch script. It's full of nothing, and therefore it's not going to work out. But the point is that a defensive operator, an EDR, or someone watching Sysmon should be able to see all of these behaviors firing, regardless of whether or not they perform an actual action from a threat intel perspective, right? So as we move forward with this, we actually are dropping another one in system 32. We're pretending to run that thing as well. And again, these install 3 and 4 are nothing. But then we get to some more interesting things. And these are the actual commands utilized by HoneyBee here with these setup.cab extractions and the like there. So we're actually firing those legitimate commands that it utilizes, word for word. Finally, once HoneyBee does all those things, it queries for some system information. Again, it does it in a variety of ways, querying for the host name, writing sysinfo to files, and then going forth and we can exfiltrate those files, which is what we're doing here. But we're also using a bespoke Scythe module, one that's included in the platform, to dump sysinfo that way. So it's a couple alternate means of doing these sorts of things, depending on the use case. And then finally, using our uploader module, we're going to go ahead and exfiltrate some of the files that we've written, in this case, temp.ini, and then we'll make a directory, put some files in that directory, we'll zip it up, encrypt it, and then exfiltrate it. And all of this has been happening automatically in the background for us. So jumping back to our campaign, we go over here, HoneyBee example, to the endpoint that has been running. And we can see it is actually still going here, but all of the operations that we expected. So going backwards, we downloaded these files, it's dropped them in all their requisite places, as you can see here. And then we went forward, we created some more files, we detonated some files, we tried to run again some of these bogus batch scripts just to see if the operators would notice. We get some successes and failures because some of these commands aren't valid in our environment because we're using some bogus files. But again, Scythe is behaving exactly as we would expect it to, because what we're trying to do is light up the IOC indicators here. Of course, we can dump all the system information. There we go. We're creating files, that's all working. Then we're performing some encryption. We're actually doing some zipping here with PowerShell. That's all working as expected. And it's worth noting that in the event we do something such as using the uploader to exfiltrate a file, we can actually grab that file right here from the Scythe interface as well, so we can see what's happening in that operation. After we performed our encryption, we finally did our exfiltration of all the things we've zipped up, all the files we wanted to steal from a HoneyBee perspective. And then we're done. I mean, that's it. It would, of course, as usual, we could always take over manual ops and do some more interesting things if we're so inclined via the shell right here in Scythe. Jumping over the reports, we can see our HoneyBee example, and we can actually generate reports, including our MITRE ATT&CK report, which is here. It's a summary of all the things that we tested for and whether or not they succeeded or failed from an adversary perspective. So here in red, these are all the things that succeeded, and the blue are the ones that did not. And a lot of those, the ones that were either blocked or failed, were due to the fact that we were using some bogus scripts or some files that weren't quite there. And in addition to our MITRE ATT&CK report, we also have our Attack Navigator script, or our Attack Navigator report, which can be automatically imported here into the MITRE ATT&CK Navigator just by clicking add and opening from local. And here are all of the TTPs that we tested for and were tagged in Scythe automatically, again with the same coloring scheme of blue means it was blocked by the blue team or failed, and red means it worked from an adversary perspective. And with that, we've just conducted HoneyBee in a matter of minutes based off the template that we had pre-created that we'll be sharing on GitHub. And hopefully between this video and the write-up, you've learned a little bit about how to perform these sorts of operations and a little bit about the HoneyBee threat actor. Thanks for your time and looking forward to the next Threat Thursday.